Good day, everyone. I'm Captain Ron Irani, and very soon I will be taking a class. But before I begin a class, I have a social message for every one of you. Please do wear a mask at all times. Please wash your hands frequently. Please avoid crowded areas. Please stay at least 2 meters away from others. And most importantly, get yourself and your family members vaccinated. It definitely works in controlling the spread of the coronavirus. At the end of the class, do give a thumbs up, subscribe to my channel, as well as click on the bell icon to get instant notifications as soon as something new is posted on my channel. In this video, I'm going to take you through the unsolved problems and help you solve them based on Simpson's rules from Capt Subramaniam's textbook on ship stability, volume 2, starting off with exercise 16, areas by Simpson's rules. Problem number 1 states that you have to find the area of the boat cover 10 meters long if its breadths at equal intervals from forward are 0, 2.25, 3, 2.25 and 0 meters. Here we see that this is the information that is given to us in the problem. The ordinates given here are full breadths. They are 5 in number. Therefore, the total number of sections is equal to 4, as you can see in the drawing on the right hand side. The length of the boat cover is 10 meters and we have 4 sections. Therefore, h is equal to 10 divided by 4, giving us 2.5 meters. So each of the ordinates here are 2.5 meters apart. Using Simpson's first rule, because we have odd number of ordinates, let's make some columns. The first column on the left is for the ordinates A, B, C, D and E. The second column is for the breadths Y. The third column is for the Simpson's multipliers. And since we have 5 ordinates, we use the multipliers 1, 4, 2, 4, 1. And the product of ordinates and Simpson's multipliers comes under this column called product. So for ordinate A, the breadth is 0, the multiplier is 1, the product is 0. For ordinate B, the breadth is 2.25, the Simpson's multiplier we use is 4, and the product 2.25 into 4 is equal to 9. For ordinate C, the breadth is 3, the Simpson's multiplier that we use here is 2, and the product is 3 into 2 equal to 6. For ordinate D, the breadth is 2.25, the Simpson's multiplier that we use is 4, and therefore the product is 9. For ordinate E, the breadth is 0, the Simpson's multiplier we use is 1, and the product is 0. Therefore, the sum of all these products is equal to 24. To find the area of the boat cover, we use Simpson's first rule, which states 1/3 multiplied by h multiplied by the sum of the products will give us the area of the boat cover. We know h is equal to 2.5 meters. We have calculated it here. We have found the sum of the products equal to 24. Thus we substitute and we find the area of the boat cover is equal to 1 by 3 into 2.5 into 24, thus giving us the area to be 20 square meters. On to problem number 2. A small coaster's deck, 50 meters long, half breadths at equal intervals from aft are 0.78, 2.89, 4.06, 2.34 and 0.31 meters, and we have to calculate the deck area. This is the information given to us in the problem. The number of ordinates, in this case the ordinates are for half breadths, also called half ordinates or semi-ordinates. They are 5 in number. Therefore, the total number of sections, as you will see in the drawing, is equal to 4. H is given to us as 10, and we have 4 sections. H is given to us as 50, and we have 4 sections, thus giving us H equal to 12.5 meters. Once again, we are going to use Simpson's first rule. But this time, please remember, we are using half ordinates, y upon 2, half breadths, whatever you wish to call them. We make 4 columns. The first column, we have the ordinates A, B, C, D, E. Second column is for the half ordinates, as given in the problem. The third column is for the multipliers, the Simpson's multipliers that we will be using, 1, 4, 2, 4, 1. And the fourth column is the product of the semi-ordinates and the Simpson's multipliers. Thus for ordinate A, semi-ordinate A, we have 0.78 into 1 equal to 0.78. For semi-ordinate B, we have 2.89 multiplied by 4 giving us 11.56. For semi-ordinate C, we have 4.06 multiplied by 2 giving us 8.12. For semi-ordinate D, 2.34. We have Simpson's multiplier 4, and that gives us a product of 9.36. And for semi-ordinate E, 0.31 multiplied by 1 gives us a product of 0.31. You add all the products, the sum of the products works out to 30.13. Now, to calculate the area of the coaster's deck, remember that we have used semi-ordinates. So to get the full area of the coaster's deck, we have to double up. We have to multiply it by 2. The Simpson's formula that we are going to use, Simpson's first rule, 1 upon 3 into H into the sum of products, and that we are going to double up or multiply by 2. Substituting the numbers, we have 2 into 1 upon 3, H is equal to 12.5, we have calculated above, and the sum of the products, 30.13, which we have also calculated above. Thus giving us the area of the coaster's deck to be equal to 251.084 square meters. Now we move on to problem number 3. Problem 3 states, find the area of a collision bulkhead 12 meters high. The half breadths at equal intervals from the top are as follows, as is given here in the problem. This is the information that is given to us in the problem. Height of the collision bulkhead 12 meters. The semi-ordinates given are here. The total number of semi-ordinates given are 7. Therefore, the total number of sections is equal to 6, as you can see in the drawing on the right hand side. And therefore, when we divide the total height, that is 12, by 6, the number of sections, we get h is equal to 2 meters. Here I am going to show you the same problem worked out using Simpson's first rule as well as Simpson's second rule. Basis Simpson's first rule. 4 columns. First column on the left, all your semi-ordinates from A to G. Half breadths or y by 2 are given over here as given to us in the problem over here. The Simpson's multipliers that we are going to use are 1, 4, 2, 4, 2, 4, 1. And when we multiply the half breadths or the semi-ordinates with the Simpson multipliers, we will get the respective ordinates. We will get the respective product for those ordinates. Therefore, sum of the products, we add up all these, 48.6, and we get the area of the collision bulkhead is equal to 2 times 1 upon 3 into h into sum of the products. Once again, we are going to double it up or multiply by 2 because we have got semi-ordinates. Thus, when we substitute the values, we have 2 multiplied by 1 upon 3 multiplied by h, which is equal to 2, and the sum of the products is 48.6, thus giving us the area is equal to 64.8 square meters. Now what if we used Simpson's second rule? The Simpson's multipliers that we would use in this case would be 1, 3, 3, 2, 3, 3, 1. The principle is the same. The semi-ordinates multiplied by the Simpson's multipliers will give us the product. When we add all the products that we have calculated, we get the sum is equal to 43.1. Now the area as per Simpson's second rule would be 2 times multiplied by into bracket 3 upon 8 into h into sum of the products. And once again we double it up or multiply it by 2 simply because the ordinates given to us are half breadths or semi-ordinates. So when we put in the numbers, values for h and the sum of the products, we get the area of the collision bulkhead is equal to 64.65 square meters. So you see, the answers are not exactly the same, but nearly the same. It does not matter which one you use in the examination. You do not have to work it out using Simpson's first rule as well as Simpson's second rule. If you use any one of them, it is good enough for the examiner to give you your full marks, provided you have solved it correctly. Problem number 4. Find the area of a transverse bulkhead 10 meters high whose half breadths at equal vertical intervals are as given over here in the problem. This is the information that we have as given in the problem. Remember that once again it is half breadths or semi-ordinates. And how many semi-ordinates do we have? 6. Therefore, the total number of sections we have are 5. The height of the bulkhead is 10 meters. And therefore, when we divide 10 by 5, we get h is equal to 2 meters. This is as the drawing on the right hand side is basis the information that is given to us in the problem. Now here once again I'm showing you solutions basis Simpson's first rule as well as second rule, and we see once we have done the multiplications, what do we get? For the semi-ordinates A, B and C, for starting from the top, we use Simpson's first rule. And for the other four ordinates, we use Simpson's second rule, 1331. Basis first rule, we have the area equal to 74 square meters. And basis second rule, for ordinates C, D, E and F, we have the area equal to 75.75 square meters. Therefore, the total area works out to 149.75 meters, square meters, sorry. Now, another alternative method of calculation is as follows. Here I am using Simpson's first rule and third rule. In Simpson's first rule, I'm going to find the area between the ordinates A, B, C, D and E. And using the Simpson's third rule, I'm going to find the ordinates between the area between the ordinates F and E. So using Simpson's first rule, 4 columns, the ordinates A, B, C, D, E. Semi-ordinates as given to us in the problem, 10, 9.3, 8.3, 7.1 and 5.7. The Simpsons multiplies 14241, and the semi-ordinates multiplied by Simpsons multiplies gives us the product. We do that for all 5 semi-ordinates, and then we finally add up and get the sum of the products to be 97.9. Therefore, area of the transverse bulkhead is equal to 2 times, because we have got semi-ordinates, we have to double up or multiply the answer by 2. 2 times 1 upon 3 into h into the sum of the products. When we put in the values for h and the sum of products, we get the area of the transverse bulkhead to be equal to 130.533 square meters. Now we have found the area until semi-ordinate E, which is 5.7, and we have to find the area now between the semi-ordinates E and F, 5.7 and 3.8. So we are going to work F is equal to the semi-ordinate F is equal to 3.8. The Simpsons multiplier is 5, product is 19. Semi-ordinate E, the Simpsons multiplier that we are going to use is 8, giving 45.6. And semi-ordinate D multiplied by Simpson's multiplier minus 1, giving us minus 7.1. The sum of the products gives us 57.5. So the area between F and E, when we work it out using Simpson's third rule, is 2 times 1 upon 12 into h into the sum of products. We substitute the value of h and sum of the products, and we get the area between F and E is equal to 19.167 square meters. We add the two areas A and B to get our final answer to be 149.7 square meters. As you see, When we used Simpson's first rule and second rule, it was 149.75. And when we used Simpson's first rule and third rule, it was 149.7 square meters. Here once again, same problem, problem number 4, worked out a little different using Simpson's second rule and first rule in that order. And we get the answer to be 140.73 square meters. Thus, you see in all three solutions, we are quite close. 149.783, 149.7, and 149.75 square meters. And what if we use the trapezoidal rule? According to the trapezoidal rule, the area of the collision bulkhead would be, since we have half ordinates, we have to obviously multiply the final answer by 2. So I'm doing it here. H multiplied by half of A, the first ordinate, plus B plus C plus D plus E plus half of the last ordinate. So 2 times, since we have to double up, H is also equal to 2 multiplied by the first ordinate is 10, so 10 divided by 2 plus 9.3 plus 8.3 plus 7.1 plus 5.7 plus half of the very last ordinate, that is 3.8. Thus, basis trapezoidal rule, the area of the collision bulkhead is equal to 149.2 square meters. Do give a thumbs up, do subscribe to my channel, as well as click on the bell icon to get an instant indication for all new postings in my channel. Thank you and goodbye.